GATE 2012 Civil Engineering question 36. Two soil specimens with identical geometric dimensions were subjected to falling head permeability tests in the laboratory under identical conditions. The fall of water head was measured after an identical time interval. The ratio of initial to final water heads for the test involving the first specimen was 1.25. If the coefficient of permeability of the second specimen is 5 times that of the first, the ratio of the initial to final water heads in the test involving the second specimen is. The four options given are A 3.05, B 3.8, C 4 and D 6.25. The relevant NPTEL reference has been listed. So, the falling head permeability test is utilized to measure the permeability of fine-grained soils such as clays. For sands, we use the constant head permeability test. The permeability is given by AL by AT into the ln of H initial by H final. Here, small a is the area of standpipe, L is the length of specimen, capital A is the area of specimen, T is the time elapsed for test, HI is the initial height, and HF is the final height in the standpipe for the water level. So based on these values, the permeability of the soil sample can be determined. In our case, it has been given that the test was done under identical conditions and the geometric dimensions of the apparatus were same. So the area of a standpipe would be the same in both the cases. The length of the specimen would also be the same. The time elapsed is also given to be identical, and the area of the specimen would also be same since the geometric dimensions are the same. So for the first specimen K1, which will be equal to A1L1 by A1T1 ln of H1 over H2. So in this case K1 will be equal to AL by AT ln of H1 by H2. This is equation 1. For the second specimen K2 will be equal to A2L2 by A2T2 ln of, let us call it H1 dash and H2 dash. It will be equal to AL by AT ln of H1 dash by H2 dash. Let us call this equation 2. It is given that the ratio of K2 by K1 is equal to 5. So substituting the values from equation 1 and equation 2 into equation 3, we would get AL by AT ln of H1 dash by H2 dash divided by AL by AT ln of H1 by H2 equals 5. So AL by AT would get cancelled out since it is the same. This would give ln H1 dash by H2 dash equals 5 times ln of H1 by H2. It has been given in the problem statement that H1 by H2 is equal to 1.25. So this would give 5 ln of 1.25, which would turn out to be 1.15. So using this, H1 dash by H2 dash will be determined as 3.049, that can be approximated to 3.05. The ratio of the initial to final water heads in the test involving the second specimen is 3.05, that is option A. The relevant NPTEL reference has been listed.